Okay, this is question 6 of the component 3 mock, the A2 paper. So, okay, this looks like nerve stuff to me. And indeed, so we've got a diagram, we've got a photograph, and then it goes on to the next page delightfully. Okay, so I've got my, calculator, ruler, pen, pencil, and my trusty highlighter. So let's go. The diagram shows part of 2 nerve fibres. Okay, 2 nerve fibres. I'm thinking that must be fibre 1, and that would be fibre. Oh, I see. This is a synapse, isn't it? And a synapse. So here's my synapse. Right, what direction are we going in? We've got vesicles in that one, so it's going that way. Okay. And then we've got also figures represent potential difference. So what do I know about potential difference? We've got the graph, haven't we? That one's plus 40. So, okay, plus 40, that's my action potential. And then minus 70, that's resting potential. And here we've got minus 90, and that's that hyperpolarization. And what else have I got? I've got my myelin sheath there. Oh, if I could spell, of course. Myelin, it's myelin. So, question. Right, draw a circle around one region. So draw a circle where the action potential, explain why you've chosen it. 2 reasons, okay, shown on the diagram, so I'm going to refer to that, which would stop the nerve impulse going in the opposite direction. So I've decided the nerve impulse is going that way. Why is it not going that way? Probably need to think about that. So, electron micrograph, transverse section of the nerve fibre at point A and B. Identify cell Z. Oh, I know that already. So that's I don't need to think about that. That's my Schwann cell. Y then is the myelin sheath. Let's try and spell it right this time. And of course the myelin sheath is wrapped round X, which therefore must be the axon. Hooray! Explain what would happen to the rate of transmission if structure Y was damaged. That's a dead easy one. I need to talk about saltatory conduction and slowing down. And then we're on to curare. Poison plant extract causes muscle paralysis, and the victim acts on the postsynaptic membrane. So this is the effect of drugs on synapses, and it stops the transmission of the nerve impulse. Suggest and explain how may prevent. So I just need to pick one of those things that slows everything down, and then suggest no effect on the heart. I probably need to think about that as well. So here we go. Let's go back and start to think. So, action potential. Draw one region of the diagram. There it is. There's my action potential. And I'm going to label it as well, just so that they know that's where my circle is. Action potential. So, explain your choice. This is the region where the inside of the axon positive. Do I need to explain why, do you think? Due to sodium ion influx, love that word, influx, causing depolarization. I don't know what else they could possibly want from me. Probably actually just saying it's plus on the inside would be enough, but you know, you can never tell, you can't see what's in the examiner's mind. Okay, give 2 reasons shown on the diagram which will prevent the nerve impulse going backwards. So why will it not go backwards? Okay, so if it's depolarized there and resting there, it can move forward, but this is hyperpolarized there. So, right, okay, reason 1. The hyperpolarization minus 90 millivolts prevents threshold being reached. So it has to go in that direction. They haven't asked us to actually label that on, have they? Okay. And then at this end we've got the vesicles in the synaptic, on the presynaptic membrane side. 2 neurotransmitter vesicles. Only on the presynaptic membrane side. Super duper. I suppose I could have possibly talked about refractory period behind here. Maybe not. Anyway, so I've done that labelling. So explain structure Y, if myelin sheath was damaged, what would happen? So the rate of transmission would slow down as saltatory conduction.
Can I read this for Dr. Saville?
You can. Welcome to the world of video. Just put it on his desk. As saltatory conduction would not take place. Okay. Okay. I like that. I've put saltatory conduction in, which is nearly always on the papers, so hurrah. Okay. Curare, muscle paralysis, so we're not sending that impulse across to the postsynaptic membrane. So I'm just sketched a little. So we're not letting in sodium ions down there. So it might be that it's blocking receptors, perhaps. That'd be a really good reason. That's a nice easy one to explain as well. So that's the one I'm going to go for. So curare. So remember, you don't need to actually know this drug at all, or any other drug. You need to be able to work out how it could possibly cause that effect. So curare has a complementary, and again one of my, oh, such a good word, complementary shape to the receptor protein. On the postsynaptic membrane. It blocks the receptor, so the neurotransmitter cannot bind. And this is great because it is just like that sort of the competitive inhibitor story, isn't it? So ooh, lots of so's in this sentence. So. It's always good to give lots of reasons and use lots of so and because words. So, the sodium ions. So the sodium ions do not depolarize the postsynaptic membrane muscle cells are not stimulated to contract, causing paralysis. Right, have I done everything that I need to? So I've talked about muscle paralysis, talked about the postsynaptic membrane, which is this one, prevention of transmission of nerve impulse, that's the sodium ion thing, suggest how, I think I've nailed it, suggest why curare has no effect on the contraction of the muscles of the heart. So what do I know about the heart and what causes contraction? So the contraction of the heart starts off at the SAN, AVN, and it doesn't really involve neurons. So, what's the word? Myogenic. So, the contraction of the heart is myogenic and doesn't involve nerves. Although I do know it's connected to the brain, obviously, but you know, I'm thinking adrenaline raises the heart rate, acts on the SA node, and therefore it's not going to be, I don't know, it's not going to be that anyway. So, there we go.